Hello everyone, welcome back to ChemONotes, your chemistry companion for clearing concepts and smart learning. Today we are going to dive in for the third part of rearrangement series. We have already seen Pinacol-Pinacolone Rearrangement. If you have not seen the first two parts, just click on the link which is on the screen so that you can see first and second part, which is based on Pinacol-Pinacolone Rearrangement. Today's session we are going to study Beckmann Rearrangement. So in this you will be studying the rearrangement. Stay tuned with ChemONotes and please like, subscribe the channel. So let us start. With the Beckmann Rearrangement. Beckmann Rearrangement is an acid catalyzed reaction where oximes are converted into amides or nitriles. So student, Beckmann Rearrangement reaction, we should first understand that it is having three things we should know. One thing is that it is acid catalyzed, then oximes are used and oximes are converted into amides and nitriles. Now acid catalyzed, so acids like concentrated H2SO4, phosphoric acid, sulfurous pentachloride, such acids we can use. Okay. Now oximes are converted into what? Amide, let us see the functional group of amide. This is your functional group. And nitrile is C triple bond N, correct? So these are the things which we can get after Beckmann rearrangement. These are the functional groups you can get. So before we begin with the Beckmann rearrangement, we will understand what oximes are. So we will be preparing oximes first. And here we are going to prepare ketoxime because it is prepared from ketone, so it is ketoxime. If it is prepared from aldehyde, then it will be called as aldoxime. Okay student, so if you are going to prepare it from aldehyde group, taking aldehyde as a starting material, then the compound will be called as aldoxime. Okay, and if it is prepared from keto group, that is both the sides R group, then it will be called as ketoxime. I think this is clear to everyone. So either aldoxime or ketoxime we can prepare. Oximes may be aldoxime or ketoxime. Now whatever on screen I am going to show you, that is we are going to prepare ketoxime, means we will be taking the starting material ketone. As you can see on the screen, a ketone, that is R C double bond O R, ketone is treated with NH2OH, that is hydroxylamine. Okay, so let me just write the names of them. This is the general reaction. So this is hydroxy. Okay, it is hydroxyamine. Hydroxyamine. So basically what is going to happen is the nitrogen hydroxyme NH2 group or the whole hydroxyme is going to attack on your keto carbonyl group. What will happen? The ketone or nitrogen carries, as we know, nitrogen carries a lone pair. So this lone pair, it will act as a nucleophile. So it is going to attack on a carbonyl group here, and oxygen will carry one of the hydrogen from nitrogen here. Okay, so basically the step goes like this: CO here on there is, let us say, O minus. Okay, let me show it in this fashion only, how it is, the way it is written in the same fashion we will write it. R, C, R. So what has happened? On this carbon we have got this group NH. Okay, HOH. Why I have written that H separately? Because this oxygen will carry O minus now, correct? When nitrogen will attack on carbon or carbonyl group, the oxygen, the pi bond will shift and oxygen will carry minus sign. So this oxygen which is carrying minus sign will grab the proton from NH2OH. So out of 2 hydrogen, 1 hydrogen will be grabbed here. So it is like this. Okay, this will be taken by oxygen, and we are going to get what? A intermediate step, that is CROH NHOH. And next step is basically there is removal of water group. Now again this oxygen is going to grab this proton, as they are very close to each other. It is going to grab this proton and shifting will take place. It is in this way. Water molecule will be removed. Okay, water molecule will be removed, and we are going to get a ketoxime. We are going to get a ketoxime. So these are step by step things which I have explained, but directly you can remember that ketone has been converted into ketoxime. Simply what has happened? A simple way to remember this is the mechanism which I have shown you, but simple way is what we can do is NH2OH. Here there is removal of water molecule, so this oxygen and hydrogens get removed. Okay, so minus H2O, and you are going to get a compound, that is, instead of oxygen there is NOH. So you're basically these 2 hydrogens and this oxygen is going to be removed as water molecule, and you are going to get a compound which is called as ketoxime. Okay, so this is in one step I have shown here how to remember it, but if you go step by step mechanism wise, this is the mechanism which you should follow. Okay, to prepare ketoxime. In the same fashion you can get aldoxime, only difference will be what? Instead of R there will be H. This is your aldoxime. Okay, aldoxime. So one of the R group, if it is replaced by hydrogen here, then the group, whatever compound you will be getting is aldoxime. Okay, so this way you can prepare any of the oxime, either aldoxime or ketoxime. So let us now see one example. This is the general reaction which I have shown you on the screen. You just take down this in your notebook, okay, or understand it by pausing the screen. You can just go through the reaction once again. Now let us see the next, that is example of ketoxime. So if we take acetone, that is CH3 C double bond O CH3, which we have shown on the screen. Okay, example of acetone we have shown here. So I'll write it down here. Acetone is reacting with your hydroxylamine. Okay, so same NH2OH is hydroxylamine. What is going to happen is removal of water molecule minus H2O, and we are going to get a ketoxime. Here you can see the R groups are replaced by CH3 group. R groups are replaced by CH3 because we have taken acetone. Okay, so this is CH3 C double bond N OH CH3. So this is your ketoxime which we will be getting. Now one thing in before we proceed for Beckmann rearrangement, you should understand the 2 isomers of ketoxime which we can have. Okay, there are 2 isomers we can have. Isomers, I'll write it here. What we are going to get? We are going to get 2 isomers. Now how are those 2 isomers? CO. Okay, these are the 2 isomers which I have shown on the screen. Now on the screen the isomers which I am showing, I did not take from acetone. I have taken a acetophenone group for preparing the ketoxime. Okay, now you may say why here R groups, one is CH3 and other is PH. Okay, Here also isomer of it, one is CH3 and pH. Now if you see the arrangement of them, you will find that, if I just draw a line here so that you can understand. Okay, it is a ketoxime where C double bond N, there is OH. Okay, here there is CH3, here there is pH. Only thing is I've shown them vertical. So horizontal if you write, it will be like this. Now if you see the arrangement, there are two different groups attached to the carbon, because they will be from the keto groups and the oxime group here. So the ketoxime which is formed, the pH and OH are, what has happened here? The pH and OH is exactly opposite to each other. So such isomer we will call as anti. Okay, and if they are on the same side, like here you can see the priority, pH will get the first priority. So this and OH, if they are on the same side, it will be syn. Okay, so syn ketoxime and anti ketoxime, what they will be known as? They are known as syn ketoxime and anti ketoxime. Okay, you should know this. Why it is important? Because in Beckmann rearrangement, these are called as, let me just rub this so that we can write the names properly. Yeah, so we will be naming them as, because this is on the same side, pH and OH, so this will be called as syn aldoxime. It is not aldoxime, it is a ketoxime, syn ketoxime, and this will be anti ketoxime. Now why we are studying this? This is because your Beckmann rearrangement is highly stereospecific. Okay, it is highly stereospecific reaction. That means you will be getting a syn will give different product and anti will give different product. Okay, syn ketoxime will give us different product and anti will give us different product. So Beckmann rearrangement is highly stereospecific, as group anti to OH group migrates and 1-2 shift takes place. What they are saying, that anti group, the group which is anti to OH is going to migrate. A rearrangement will take place. 1-2 shift will take place only for that group which is anti to OH. Okay. For example, here you can find which group is going to migrate here, the group which is opposite to the OH. Okay. So let us see the Beckmann rearrangement reaction. So once the ketoxime is prepared, what we have to do? We are going to convert it into amide, N substituted amide. So this reaction is called as Beckmann rearrangement. What we are doing? We are converting ketoxime into N substituted amide, and aldoxime will be converted into N substituted, or it will be called as nitrile. Okay, C triple bond N we can convert it into. Now let us begin with the example before we start with the mechanism. So now I think everyone is clear what is ketoxime. R, C double bond, N, OH, and there is on carbon the fourth valency is satisfied by R. So it is a ketoxime. So in the acidic medium, it will get converted into, the rearrangement will take place, that is 1-2 shift will take place. 1-2 shift will take place in the second we can say step, and you are going to get a product which is known as N substituted amide. Why it is called as N substituted? Because on nitrogen there is a R group. Okay, on nitrogen there is a R group. So that R group, here you can see one of the R groups gets migrated here like this. Okay, so it is N substituted amide you can get. This group is called as amide. Okay, that is C double bond O NH group amide. So let us see the example. Example we have taken here is a ketoxime prepared from a ketone which is C double bond O pH CH3. So this ketone has been converted into ketoxime. The ketoxime will be simple that is PH, CH3, double bond NOH. So that is the starting material. This is your ketoxime which we have prepared from this ketone. Okay. So once the ketoxime we are going to get, then treat with acid, and there will be what migration will be taking place. 1,2 shift will take place, and the group which is anti to OH, you can see here. Which group is anti to OH? There is phenyl group. So selectivity is also one of the thing. Okay, where the group which is anti to OH group is going to migrate. So here in this case, the group which is anti to OH is phenyl group. Okay, so what is going to happen? This phenyl group is going to migrate, and there is formation of what? N substituted amide. Okay, so let us see the mechanism. Now you may wonder, when pH shifts here, what happens? How come OH is getting converted into on carbon? So let us see the mechanism, how the amide is formed. So here I have shown that a group anti to OH will migrate, and there will be either syn or anti isomer formed. So let us see the mechanism of Beckmann rearrangement. So first thing we are going to do is we are going to do the protonation of ketoxime. The OH group which is there on the ketoxime, here we have taken the example of ketoxime, that is we are going to see CH3, CH3 double bond, instead of double bond O there is NOH, that is ketoxime. So here the ketoxime, first step is the lone pair of oxygen is going to grab a proton and it is going to get protonated. Okay, the H plus ion from acid will be grabbed by your lone pair of oxygen, and it carries a positive charge. So it forms OH will get converted into OH2, okay, by grabbing the proton, and oxygen will carry, because oxygen has used his lone pair, so it will carry a positive charge. This is the first step. Now second step, what happens is, after protonation of ketoxime, there is 1,2 shift which is going to take place. Okay, 1,2 shift is going to take place. Now we know that the group which is anti to OH gets shifted. So here this CH3 which is anti to OH is going to migrate or shift. So while shifting, it is going to remove water molecule. Okay, to stabilize the positive charge, the water molecule will get eliminated, and you are going to get a straight CH3 C double bond N CH3. Now as carbon has lost one valency, that is CH3 has shifted on the nitrogen, so carbon will carry a positive charge. Okay, so there is a formation of carbocation. Now again we have to stabilize this carbocation. So what happens is, the water molecule which was eliminated will attack on that carbocation, and here you can find there is a bond formation between oxygen and water molecule, carbon and water molecule oxygen. So there is a bond formation. So this is your second step. Now once this has formed, next step is there is elimination of nitrogen, hydrogen. Proton will be eliminated. Okay, as oxygen will carry, what will happen? Oxygen, because it has made a bond with carbon with using its lone pair, once it uses its lone pair, it will carry a positive charge. Okay, it is going to carry a positive charge. So to stabilize this positive charge, the proton is removed. Okay, so you can see minus H, and you are going to get a enol formation, that is CH3 COH, one of the hydrogen from water molecule has been removed, double bond N CH3. So this is in the form of enol. Now we know that enol immediately gets converted into keto form, but here as the keto form is as amide, so what is going to happen is, this nitrogen is going to grab this proton, the bond is going to shift here, and nitrogen, whatever positive charge it will get, this pi bond will stabilize that positive charge on nitrogen, and this way we are going to get a amide formation. Okay, so this is this whole step from first step till end N substituted amide we are getting, N substituted amide. So this reaction is called as Beckmann rearrangement reaction. Okay, student. So if you have any doubt, anything, if you want this explanation in Hindi, just comment below. I can tell the same thing in Hindi in the next video. I'll prepare one similar video in Hindi and I can explain you this. So just comment below if you want the same thing in Hindi or Marathi also. So let us go to some questions which are asked in the NET/CET exams or CET exams. Okay. So these are the questions which they can ask on Beckmann rearrangement. There is a cyclohexanone. The compound written here is cyclohexanone. So such type of reaction they can give and ask what is A and B. Options may be given and you have to select those A and B option. Okay. Now we know that ketone and oxime, if it is there, what is the A product you should get? It is a ketoxime. Correct, student? Now you know that it forms a ketoxime. And ketoxime when treated with acid gives us a Beckmann product, that is N substituted amide. So this is how once you see the reaction you can know if you know the reaction. Okay, so let us see the reaction how it goes. So let me rub this part for a while and we can write the So this cyclohexanone when reacts with oxime, what happens is it forms a ketoxime. No, it is a cyclic ketoxime. It is cyclic ketoxime. Okay, cyclic ketoxime when treated with acid, there is a what will happen? Increase in the chain carbon cycle. That is, it is going to 6-membered ring has become 7-membered ring. If you count the carbons here, it is 1, 2, let me change the color, 1, 2, 3, 4, 5, 6. And if you see the product, it is here. Let us start from nitrogen, 1, 2, 3, 4, 5, 6 and 7. So it has become 7-membered ring. Okay. So what happens is, we know the step, that first step will be protonation. So this group will get protonated, correct? After protonation, there is shifting will take place. So while shifting, what happens is, either this 1,2 bond or 1,6 bond will shift here. So we know that the bond which is anti to OH is going to shift. So let us say 1,6 bond shifts here and your OH group which was protonated will get eliminated. So there is minus water molecule. Okay. After this, what will happen? There is again attack of OH group on the carbon which is having a positive charge. Correct. So this way we are going to get this compound, and this compound is known as what? The compound is known as caprolactam. The compound is known as caprolactam. Okay. So let me show the intermediate step here. So whenever there is a 7-membered ring, this is how the 7-membered ring will be. Okay, 7-membered ring. What has happened is OH has been eliminated and there is a double bond with a carbon here, and this carbon will carry a positive charge. This carbon will carry a positive charge. Now next step, what will happen? The water molecule which was eliminated will attack on the positive charge, correct? And shifting will take place, and this ultimately you will be getting this group, that is a enol formation. Now enol will get converted into amide. Enol will get converted into, this is known as enol formation. Enol will get converted into amide, and the name of this compound is caprolactam. Okay, students, and you know that caprolactam is one of the starting material for nylon 6. So this way caprolactam can be used for synthesis of nylon 6. So Beckmann rearrangement application is preparation of one of the application, that caprolactam we can prepare, which is used for the synthesis of nylon 6. Okay, so one of the important reaction of Beckmann rearrangement. This is one of the important reaction of Beckmann rearrangement. Now next question you can see here, there are a few questions I have shown for practice also. We can directly write the products now. You know how to do it. Mechanism will not see. We'll directly try to write the products. Yes. Tell me student, what is the starting material here? If you can see the starting material, it is a oxime, but it is a aldoxime because one of the group is hydrogen. So it is a aldoxime. Okay students. So aldoxime. Now tell me which of the group is going to shift here? The group which is anti. Now here the group which is anti is your hydrogen. So hydrogen will shift and you are going to get a product, that is CH3 C double bond NH, correct? And here what will happen after the plus sign will be there, water molecule will attack and you are going to get the first thing, that is CH3 COH double bond NH. Okay, and at last you can convert this as CH3 C double bond O NH and H. So you are going to get a amide. Okay, you are going to get a amide here, that is CH3 C double bond O NH2. So this is how you can use your Beckmann rearrangement and proceed. Now tell me the second one. What is the product we are going to get for second? Directly we will write the product now. There are two phenyl rings. So phenyl rings, I can write it as PH also. Instead of showing the phenyl groups rings here, I'll show it with PH. PH C double bond N PH and H. Okay, so this is your N substituted amide after Beckmann rearrangement. I can directly now write it, correct? So looking at the reaction, we can directly write the products. So you can just do the mechanism on your notebook and see whether you are getting the same product which I have written here. Okay student. So the next two you can do it as a practice. This is for your practice. Tell me in the comments whether you could solve this, and tell the answers also what you got. Okay, I'll pause for 1 second. You can take down these questions, and there are on the screen you can see some links here. You can just go and click them and go for the other chemical science practice. You can have some links on the screen and you can click and go and watch those videos. So thank you for watching. Stay tuned with ChemONotes for more such informative rearrangement reactions. Okay, we are doing the series of rearrangement reactions. So different rearrangement reactions we are going to see. Then those who are going to appear for NET and CET exam, there are some solved papers of CET exams I've solved. There are videos which are there. You can go and click those and watch them. And if you like the video, just click the bell button so that you can get the notifications. Okay, like the video, share the video, and subscribe. Ask your friends to subscribe it. Till then, bye. Happy learning.